You ever look at a streetlight or the lights at a stadium and just wonder, how do we actually know they're going to perform the way they're supposed to? It all comes down to how we measure light. And believe me, a huge shift in technology has completely changed the rules of the game.
And that question, as simple as it sounds, is really at the heart of what we're talking about today. It's all about trust and reliability. And the answer lies in two totally different ways of thinking about what a light fixture even is. All right, so here's the plan. We're going to start by jumping back in time to look at traditional lighting. Then we'll see how LEDs just blew everything up. We'll explore the new, modern way of measuring, put the two methods head to head, and then, most importantly, we'll talk about why any of this actually matters in the real world.
Okay, so first we've got to take a step back. For, decades, high-performance lighting was basically a world of separate, interchangeable parts, kind of like building with Legos.
So what you're looking at here is a high-intensity discharge tube, or HID for short. You can think of this as the engine of an old-school light fixture. It was powerful, for sure, but it was just one component in a much larger machine.
And the key thing to get here is that these systems were totally modular. You had the lamp itself, then you had a separate power supply called a ballast that you needed to get it fired up, and then you had the housing, or the luminaire, which was really just a big reflector to point the light. You could literally mix and match parts from all different manufacturers.
Now, because all the parts were separate, it kind of made sense to measure them separately, right? This method, called relative photometry, didn't measure the actual light output, no. It just tested the efficiency of the reflector housing and gave you a percentage. You'd then have to multiply that efficiency by the theoretical output of whatever lamp and ballast you picked to get a rough, and I mean rough, estimate of how it would all perform together.
But then, a new technology showed up and just turned this entire way of thinking completely on its head, and that was solid-state lighting, or as we all know them, LEDs.
Unlike that old mix-and-match system, a modern LED luminaire is a totally different beast. It's a single, sealed, completely integrated unit. The light source, the electronics, the lenses, they're all designed from the ground up to work together as one inseparable system.
And this is really the core of the problem for the old method. An LED's performance is hugely affected by heat, and the heat is managed by the housing it's built into. The driver, that's the power supply, its efficiency is baked into the whole circuit. You can't just test these pieces by themselves anymore and hope to get a real answer. It's all connected.
So, this new, integrated technology demanded a new, more holistic way to measure performance, one that treated the light fixture as the single, complete product that it is.
And that, right there, is absolute photometry. It doesn't guess, it doesn't estimate, it takes the entire finished product, puts it in a highly specialized machine, and measures its true real-world performance. Just like it says on the screen, what you test is what you get. It accounts for every single loss, from heat, from the electronics, from the lenses, everything.
This new approach was so critical that it was actually formalized in an industry standard called LM79. You can think of it as the official rule book for getting honest, repeatable measurements for all modern lighting products.
So how's it done? Well, with this incredible machine called a goniophotometer. It's basically a highly precise, robotic light meter that painstakingly measures the light coming from the fixture from thousands, literally thousands of different angles. All of that data then gets combined to create this complete 3D map of exactly how that light performs in the real world.
All right, so let's put these two methods right next to each other, because when you see them side by side, the difference is just crystal clear.
So on one side, you've got an estimate based on theoretical parts that you hope will work well together. And on the other, you have the ground truth, a real measurement of the final product. It's the difference between doing a calculation on paper and actually running the experiment for real. And this table just sums it all up perfectly. Relative photometry is just measuring efficiency, and it completely ignores all those system losses. Absolute photometry measures the actual light output, and it includes every single one of those critical losses. One was fine for the old world of interchangeable parts. The other is absolutely essential for today's integrated systems.
Okay, I know this all sounds super technical, but why is this shift so important? Well, the answer affects our safety every single day, it affects our environment, and it has some major financial consequences. So think about an engineer designing the lighting for a new highway. They use special software like Dilux or AGI32, and they feed this photometric data into it.
If that data is just a rough estimate, the real-world result could be dangerously dark patches, or the opposite, wasted energy, sky-high electricity bills, and tons of light pollution. Using absolute data means the design on the computer is what you actually get, which makes everything safer, more reliable, and way more cost-effective. And get this, the old HID tech was notoriously unpredictable. The light output could swing by plus or minus 20% over its life. That's a massive variable. It was a total nightmare for designers trying to guarantee a certain level of safety years down the road.
Now contrast that chaos with the modern approach. Standards like LM80 require LEDs to be tested for at least 6,000 hours just to predict their long-term performance. This creates incredible predictability, but it's only meaningful because it's built on a foundation of an accurate, absolute measurement right from day one.
You know, at its core, this is really about scientific rigor. There's this principle called traceability, and it's fundamental. It means you can trust a measurement from a lab because it's linked all the way back to a national standard through a documented, unbroken chain. Absolute photometry is a critical, unbreakable link in that chain. So, the bottom line is this. Our lighting technology grew up. It evolved from a simple collection of parts into a single, complex system. And to understand it properly, our measurement philosophy had to evolve right along with it, from making an educated guess to knowing the ground truth.
And really, this isn't just about lighting. This same exact shift from analyzing separate parts to measuring the whole integrated system is happening everywhere. In our cars, in our computers, in the phones in our pockets. Which kind of leaves us with one final thought. Where else are we still just estimating when we should be measuring the real thing?